Hello to everybody. Thank you all for coming. My name is Alexandria, and this summer I had the opportunity to work with Dr. Catherine Leininger at CU Boulder, and our research project focused on the influence of large wood jams on floodplain soil moisture. So I'd like to begin my presentation by talking about what large wood is. Can you still hear me okay? Is that good? Okay, perfect. All right, so I'd like to begin by defining large wood. So large wood is a piece of dead downed wood that is greater than 10 centimeters in diameter and longer than 1 meter in length. A jam consists of 3 connected pieces of this large wood. There have been, oh, hello. All right. All right, okay. So there have been limited studies on large wood within floodplains. These studies didn't begin until after human altercation. And wood removal has been commonly seen as a negative thing to the public. So it's been historically removed for things such as aesthetics, as well as useful things like navigation. So a better understanding of the dynamic of large wood within the river network will ultimately lead to better management of our networks generally. So the question still remains, how did all of this large wood get here in the first place? There are many different factors that contribute to the deposition of large wood, and these include forest, hill slope, biota, network dynamics, channel dynamics, such as the bank erosion that can deposit to this, the large wood bulk in the river, and valley bottom dynamics, and hill slope. All right, so there have been many benefits seen through multiple studies on large wood, such as promoting seedling establishment, increasing nutrients in the soil, and modifying geomorphic processes. Now, our main motivation for the study is the seedling establishment and nutrient studies. They attribute those benefits to possibly indicating those benefits, they attribute those benefits to a higher soil moisture underneath the large woods, but that hasn't been directly tested. So that is what our study intends to find, whether or not soil moisture is higher underneath these large wood jams compared to adjacent to these jams. So our study area consisted of two rivers in northern Colorado that had large-scale flood events. The first one being Roaring River, which had a flood in 1982 from a dam breakage, and West Creek, which had a flood in 2013 from over-average precipitation. So there are many influences on floodplain soil moisture, and I just wanted to go over those very quickly. Elevation above channel, vegetation type, organic matter, which is usually indicated by the soil color, canopy cover, tree density, and the grain size of the sediments. So for our data collection, we try to factor in as many of those different influences as possible by collecting forest characteristic data, such as canopy coverage, which we collected using a convex spatial densitometer, which you can see on the right side of this slide. And for our soil moisture measurements, we used a soil moisture sensor probe, which is shown here in the picture to your left. And we used a couple different sampling techniques to get these measurements. So we separated each jam into 4 different orientations. We have a riverside, upstream, valley side, and downstream orientation. And at each of these sides, we had a pair of data collection underneath the jam and then a location adjacent from the jam. And so at each of these sample sites, as you can see, this yellow star here at the jam valley side location, we have a sample of one of those measurements here. And so we took 3 different measurements, one at the organic layer, one at the mineral layer, and then 20 centimeters below the start of that mineral layer. And these are example water content percentages from those. All right, so for our results, we decided to split up the data a little bit due to the variation in weather that we had during data collection. We were in the field a total of about 5 different days within a 2-month period, so we saw a lot of rain as it being Colorado. So we decided to split it up between data that was influenced by recent rain and not influenced by recent rain. So we ran statistical tests which gave us a p-value, and we used the level of significance of 0.05. So for our mineral moisture readings by location, we separated it by adjacent versus jam and soil moisture percentage on the y-axis. So for the data not influenced by recent rain, we did not see a significant difference shown here versus the 2 locations. And then with the data influenced by recent rain, we did see a significant difference with the adjacent readings being higher. So with organic layer moisture readings, it's the same setup. We used the same level of significance and separated the location the same way with jam versus adjacent. And soil moisture percentage on the y-axis again. Here, we did not see any significant differences between the 2 locations. And so referencing back to this flowchart of the influences on floodplain soil moisture, seeing as though we didn't really see the data supporting our initial hypotheses, we decided to look at different influences that might have affected those readings. And so we began by looking at canopy coverage and how that relates to soil moisture percentage. And so as you can see here, the p-value does not support this correlation between the canopy coverage and soil moisture. So there isn't even a visual correlation that you can see here. As for soil color, when we tested the relationship between soil color and soil moisture, there was a significant difference that was supported by its p-value, where we see the darker soils having a higher soil moisture. And the same goes for the grain size. We see a significant difference with the finer soils having a higher soil moisture percentage. And we tested an additional difference between the jam and adjacent locations, which was the organic layer thickness, which we measured in centimeters, and how that relates to the location, which is, again, adjacent versus jam. And we found that with the statistically supported data, that the jam readings were higher or had a thicker organic layer. So to circle back to the original research question, we wanted to see if the large wood jams had an influence on making the soil moisture higher underneath these jams. And we did not find a significant difference in the soil moisture underneath the jams in the data taken without recent rainfall. However, we did see a difference in the adjacent readings being higher in soil moisture with the data with recent rainfall, and this is most likely due to the jams protecting the soil moisture underneath and impeding the water infiltration. And we also found that grain size and soil color strongly correlates with soil moisture, and that it showed that the lighter and coarser soils contained a lower soil moisture. So some suggestions for future research. We had a high variability with our data, so this highlights the need to have a longer and more continuous period of data collection for the soil moisture in order to see like a longer-term trend for the soil moisture. And we found the organic layer being thicker underneath the jams, which could possibly indicate that over a longer time span, we would be able to see an influence on soil moisture once that organic layer is incorporated into the subsurface. Now, by looking at the dynamic of large wood and how it interacts with the floodplains, we begin to have a better understanding of our river networks. And large wood is used for a lot of river restoration efforts, and this better understanding of large wood can overall improve our understanding of river networks and improve the management and restoration. I'd like to thank Molly, Anna, and Julie for the help in the field, Nadine Reitman for my communication mentorship, Dr. Leininger for a great project and mentorship, and I'd like to thank UNAPCO 2019 cohort and staff for all of the professional and personal supports, and thank you to National Science Foundation for funding and the support also, and thank you to all of you for your time and listening, and I'd be happy to answer any questions.
we have a microphone.
Oh,
We have
sweet.
folks Skyping, and otherwise they won't be able to hear you.
So as far as the mineral layer, did you do any sort of research as far as the any sort of differences in grain size adjacent or behind the large wood jams?
In terms of like research, what do you mean?
Well, you mentioned before that grain size had a larger impact on moisture retention. So was there any sort of did you look at all? Did you notice any difference in grain size?
Yeah, I saw like in the field, just like speaking from field experience, I saw like generally there was more like sandy soils underneath the jams that were closer to the channel. So that was also a factor that we didn't look at, the relationship of like the distance from the channel. So yeah, as Andy said, 9 weeks of an internship. We didn't have a lot of time to expand upon. But yeah, that would be interesting to look at, definitely.
So you said that when you were deciding what locations you wanted to study at,
Mm-hmm.
you focused on areas that had major flood events.
Mm-hmm.
Did you notice any differences with the fact that one was flooded in 1982 and one was in 2013?
Yeah, so actually when we went out to Roaring River for the first time, my mentor, Catherine, hadn't been there either, so it was just kind of us both scouting out the area for the first time. And we saw a lot of burn scars, which we weren't sure like if that had an effect on the log jams or if that happened before or after. So just different factors that had influenced the log jams that, it happened in 1982 compared to 2013. So just more exposure, I guess, is what I noticed.
Any more questions for Alex? Alex, I have a question.
Yes.
Can you show us how that densiometer works? I know you showed me at one point, but
Absolutely. I'll go back to the picture. Okay, so it's a grid system of, just boxes, and you separate each box into 4 different dots, and then you count all of the dots that have less than a quarter coverage. So, as in, like for this box here, for example, you'd count 1, probably 1, maybe 2 here, and then you total that up, and then you average out, or it's like you plug it into an equation, and that gives you the total canopy coverage, or actually the canopy opening, so then you subtract that by 100, and then you get canopy coverage.
neat. And then is that mirror domed or is it convex?
It's a convex, yeah.
Neat, thank you.
Yeah, thank you.
Anyone else? Okay, let me get over there.
So I'm curious about how you used the data you collected from your densiometer
Mm-hmm.
in your research.
Yeah, so for the, I'll go back to the plot. So I built a data table, and I transferred that into RStudio, and I made a scatter plot with just like basic R, and just compared the canopy coverage versus soil moisture. And then I subsetted the canopy coverage into jam versus adjacent to show the 2 different relationships there. Did that answer your question? Okay, awesome.
Right, well, let's thank Alex one more time.